algebra and geometry? Yuck! But Miss Pocket Roni can help you.
Okay, we're going to be doing a triangle proofs. We're going to be proving two triangles congruent using side, side, side and side, angle, side. I tell you right here, SSS means side, side, side. SAS means side, angle, side. And we will be dealing with the angle in between the two sides. I will show you as we go on. Remember we said that if we have a triangle, just one triangle, there are 6 parts to it. There are 3 sides and 3 angles. So there are 6 parts to every triangle. If we have 2 triangles that are congruent, and remember in my ideal world, these are drawn exactly the same, although I'm not perfect, but we're going to pretend that these are ideal, that they look the same and that they are congruent. So if I told you that this side was 10 and this was 10 and this was 12 and that's 12 and this is 7 and that's 7, you would agree that all of these measures are the same. This side corresponds to that side. This side corresponds to that 12. This 7 corresponds to this 7. And you would agree that these two triangles are congruent. Which means if we can prove that all 3 sides are from one triangle are congruent to another triangle, then we can prove that the two triangles are congruent by the tool or theorem of side, side, side. I just say tool. We're going to say that these are tools in our toolbox, side, side, side. Okay, well let's say that we know that this side is 10 and that side is 12. Let's just say we don't know the third side. But yeah, we are told that this angle is 56 degrees and that this angle is 56 degrees. If we know that these two sides and this angle is 56 degrees, then we can say that these two triangles are congruent because of side, angle, side. We know 2 sides and we know the angle in between the 2 sides. And so we say that these two triangles are congruent by side, angle, side. What you're going to learn in proofs is that you only need to know 3 parts. SSS, that was 3 things. SAS, that was 3 things. That you will need to know 3 parts of the 6 pieces to be able to prove 2 triangles congruent. And today we're only going to be talking about 2 of these things in our toolbox, side, 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 and side, angle, side. Remember, the angle has to be in between the 2 sides that are given, that you know. Okay, when we're dealing with proofs, there are 5 parts to every proof. The 5 parts are, you're going to have a figure or drawing, you will have a given statement, you will be told what you need to prove, then after that, after these 3 things, you will make statements that you are entering into evidence, just as you're going to court. When you go to court to prove someone is guilty or not guilty, you have to enter evidence into the system. So our statements, we will be entering evidence in to prove the triangle's congruent. And then the last thing, we will say reasons for the evidence that we are entering in. So just as you enter in evidence into a court, you say why you're entering that evidence in, because it shows guilt or not guilt, for a person's innocence or to convict them. So these are the 5 things that we will have. So if you can just remember proofs, as you're proving triangles congruent, it's just like in a court system of proving someone guilt or proving their innocence. Okay, we're looking at 24A, 9 through 14. We have this drawing right here. We have our givens, and we have what we're trying to prove. So we are told that in the given, that line segment AB is congruent to line segment CB. Notice how they actually use their corresponding parts. Point A corresponds to point C, and so they say AB, and since they're going to say AB, they're going to say CB. So since AB is congruent to line segment CB, we can mark that. Then AD is congruent to CD, so AD is congruent to CD. We want to use different markings. So since these 2 are congruent, we want to use different markings than these 2 so we don't show that all 4 of them are congruent to each other. Okay, so use different markings. The one other thing that we know is that BD is going to be the same line for both triangles. So BD is congruent to itself. And again, we want to use yet a third marking so that we don't get confused that this is congruent to anything else. Okay? This is like a scalene triangle, no sides are congruent. So you need to make sure that all your markings are different. If we just look at one triangle, we can see that we've marked a side, and a side for one triangle, which means we can prove that these two triangles are congruent by side postulate. I usually write SSS off to the side because in it I know how I'm proving this by, and it helps me to keep track of the statements I make. Because now I need to make a statement for each one of these sides in my statements and reasons. The very first thing you always do in your statements is to write down your givens. You're entering this into a court of evidence, and so the first thing you enter is the things that you are given. So we can say that line segment AB is congruent to line segment CB. How do we know that? Because it is given to us. Now, does it matter which one of these I write first? No. I just need to put them both in. Then we have line segment AD is congruent to line segment CD. Why? Because it was given to us. So that was one of the sides that was congruent. This was another side that was congruent. So we have to write down our information for our third side. Our third side was line segment BD was congruent to itself. If you look on your axiom sheet for something that's congruent to itself, that would be the reflexive property. It's like looking in the mirror at your reflection. You are looking at yourself. And so itself, congruent to itself, is the reflexive property. It's not reflection, but it's real similar, reflexive. And so that is our last side. So now that we've made a statement about every side, we have to make sure that we have a statement about every side in order to use side postulate. So since we have a statement about every side, and for side, we can now say that triangle ABD is congruent to triangle CBD. Why? Because of the side postulate. Okay, now we're going to be looking at 24D, 1 through 4, and we're looking at this figure right here. And our given says that triangle CDF is an isosceles triangle whose short side is line segment FD. What do we know about isosceles triangles? Isosceles triangles have two sides that are congruent, and also the opposite two angles are congruent. Okay, so the fact that we're told that CDF is the isosceles triangle, and this is the short side, which means that these other ones are the ones that are congruent, okay? These are the two sides that are congruent on that triangle, which also tells us that these bottom angles are congruent, but I'm not going to mark those right now. Okay, then we are also told that line segment CM, this line right here, bisects angle FCD. If this angle is bisected, it means that these two angles right there are congruent. Then there's one other thing that we know. This line right here, this line is the same side for both triangles. So therefore that would be the reflexive property. I am going to mark this marking with a different marking than these because this line is not congruent to this line. So since I've already used one dash to mark these congruent, I need to use a double dash to mark that this reflexive is congruent. Okay? And now I can see if I just look at one triangle. Let's look at this left triangle. I have marked a side, an angle, and another side. And I have marked the angle in between these two sides. So therefore I can prove that these two triangles are congruent by side, angle, side. Side, angle, side. Now I need to make a statement for each one of these that I've marked. I need to make a statement for this side, for this angle, and for this side in order to show that these two triangles are congruent. Okay, now I'm ready to make a statement about everything that I have marked in my picture. If you mark your picture correctly, it will be easier to make the statements. The very first statement you always make is anything that is in your givens. You have to say your givens first and enter those into evidence first. So the very first thing that we are told is that triangle CDF is an isosceles triangle. I do a lot of abbreviations. Triangle CDF is an isosceles triangle, and I'm not going to write that the short side is line segment FD. So triangle CDF is an isosceles triangle. Why? Because it was given to me. The next thing that I was given was that line segment CM bisects angle FCD. That is very important to say. So line segment CM bisects angle FCD. Why? Because it was given to me. Now I'm ready to make statements about everything that I marked up here. Okay, so first off I'm going to say this side. So I'm going to say line segment CF. And if I say with the corresponding parts, point F corresponds with point D. So I'm going to say line segment CF is congruent to line segment CD. This marking matches this marking, so that's what I need to say together. So line segment CF is congruent to line segment CD. Why were those two line segments congruent? Because it was an isosceles triangle. So from your axiom sheet, you can go look up the definition of isosceles triangle, but we can just write definition of isosceles triangle. Then we can write our next statement. You're going to ask me, does it matter which order you write these statements in? No, but you need to write that this angle was bisected before you write that these angles are congruent. So, but as far as, can I put this angle before this statement? Yes. Can I put the reflexive statement before these other ones? Yes. So, in some cases, it doesn't matter what order you write it in unless you are told something bisects something else. You need to say that. Then you can make a statement saying that two things are congruent. Now I'm going to say that these two angles are congruent. So make sure you get this right. Angle FCM. This is that little angle right there. Angle FCM. Angle FCM is congruent to angle DCM. Angle DCM. Why? Because earlier I was told that it was bisected. It is important that this statement gets made before this statement. So number 2 has to be made before number 4. But number 3 and 4 can be written in any order. So the reason that those two angles are congruent is because definition of bisector. If you go look up an angle being bisected on your axiom sheet, so you can write definition of bisector. Okay, so I've made a statement for this line, for this marking. I've made a statement for this marking. Now I've got to make a statement for this marking. So line segment CM is congruent to itself in both triangles. Why is that? The reflexive property. And you can just write reflexive. So this was a statement about a side, this was a statement about an angle, and this was a statement about a side. So I have now said all my statements about my side, angle, side. Okay, now that we have all the statements that we need, we have side and an angle and a side, we can now say that the two triangles are congruent. So we're going to say that triangle CDM is congruent to triangle CFM. Why? Because of side, angle, side postulate. Okay, we're going to be looking at 24B, 17 through 21. And we have this picture here. And this problem will show you why I don't necessarily like to fill in the blanks for your statements and reasons, because this triangle can actually be proved, these two triangles can be proved congruent by either side, 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 or side, angle, side. And I'm going to show you both of those. In the given, we are told that C is the midpoint of line segment BE and line segment AD. So let's just go back. C is the midpoint of line segment BE. If C is the midpoint of line segment BE, that means this line is congruent to that line. If C is the midpoint of AD, C is the midpoint of this line right here, it means that these two lines are congruent to each other. We want to use different markings to show that this is not congruent to this. Okay? And then we are also told that line segment ED is congruent to line segment ED is congruent to line segment BA. Okay, and again we say ED because E corresponds with B, so then we say BA. ED to BA. Again, use different markings so that nothing looks like it's congruent to each other. This is congruent to this is congruent to this, and this is congruent to this. Okay? So looking at one triangle, we can see that every side was marked, so we can show that these two triangles are congruent by side postulate. In a minute, I'm going to show you how we can use SAS. Okay, now we go down to our statements and our reasons. The very first thing you always do is state your given. Okay, so given C is midpoint of, I'm just going to do one at a time, of line segment BE. Well, I'll go ahead and put and AD. Why? That was a given. Number 2 given was line segment ED is congruent to line segment BA. Why? That was a given. Okay? Now we can say this was one of our sides, so that was a side, that was an S. Now that we know, it is important that C is the midpoint of BE be stated before we say that EC is congruent to BC. Okay? The fact that it's a midpoint, that needs to be stated before you can say those two things are congruent. Because if you could just go over here and say that these two things are congruent, why? Definition of midpoint, but you've never even made the statement of anything to do with the midpoint. So it's important you make the statement about the midpoint before going on to show any other evidence. Okay? Some evidence needs to be put in a certain order and some evidence doesn't. So now we can say EC is congruent to BC. So line segment EC is congruent to line segment BC. Why? Definition of a midpoint. When there's a midpoint, two line segments are congruent. That was one of your sides. Then we can make the statement that DC is congruent to AC. Same reason, DC is congruent to AC. Why? Because the definition of a midpoint. And that was our third side. So we have all of our sides. We have made a statement for every one of our sides. So now we are ready to say that the two triangles are congruent. So now we can say triangle ABC is congruent to triangle DEC. Why? Because of the side postulate. Now let's go back and look at the triangle again. Okay? What else do we know? What do we know about these two angles right there? What kind of angles are those? They are vertical angles. And vertical angles are congruent. You can look at your axiom postulate. Vertical angles are congruent. So we can prove these two triangles congruent also by side, angle, side. This angle is in between these two sides. So we wouldn't necessarily need to make a statement about the information that they give us that was given. We can make a statement about this side, this angle, and this side and use SAS. So then in our statements, we can still list the given. It's just evidence that we don't necessarily need. So in our statements, we can say the first thing about C is the midpoint for those two line segments. I would write it out. I'm just being short here. For those two line segments, write that out. That's a given. Now you can make the same statements that you did over here. Okay? You can say that DC is congruent to AC because of the midpoint. And that's one side. You can make the statement that EC is congruent to BC because of the midpoint, definition of midpoint, that's a side. And then your angle, your vertical angle, you would say angle ECD is congruent to BCA. Why? Because vertical angles. Vertical angles, you can write out the word angles, vertical angles are congruent. Now that's your angle. Now you've made a statement for your side, your angle, and your side. Now you can show that the two triangles are congruent. ABC is congruent to triangle DECY because of side, angle, side. So this just goes to show that sometimes problems can be proved congruent in two different ways.